All right. Be watching Google Classroom here, guys. As we wrap up, I'll be making some announcements as we get towards the end to follow the email that you should have got about deadlines coming up. So to follow that, I'll be making some announcements when some of these things are due. Let me answer the questions from yesterday. We've just got a couple other things to do this week, and we'll be wrapping it up towards the end here. You're getting towards the end. I had you do percent of change. So the first one was to go from 60 to 80. So you have to remember, found the amount of change, so it changed by 20 over the original equals R over 100. Cross multiply. Okay, so I just 2,000 from 20 times 100, 60R. And now isolate your R, and that's going to be 33.3% rounded to the nearest tenth. Remember, you do not move the decimals. That's going to be your percent. You don't have to put equals R, but that's what that comes out. Remember, you don't have to move the decimals because that's what we're doing right here. We're already making it a percent because there's no reason to have the decimal on this. It's just to get the percent. So that's why we do the equals R over 100. So that's 33.3% change to go from 60 to 80. Okay. Number 2 was to go from 57 to 97. Okay, so you had a change of 40. That's by subtracting 57 from 97. Okay, and that's over 57, the original. And you set that equal to R over 100. Cross multiply. Okay, so that's 4,000, that's 57R. Divide by 57, and you get 70.17, so that's going to round to 70.2%. Okay, 70.2% of increase, it increased there. Okay. Number 3, you had 50 to 25. Okay, now this one, if you think about it, to drop 25, you drop by 50%. 50% of 50 is 25, so to drop is 50%. But let's check that, make sure. Subtract them, you get 25. That's your amount of change over the original amount. Set R equals 100. Cross multiply, 2,500 equals 50R. Divide by 50, and you get 50%. Okay, 2,500 divided by 50 is 50, so it's 50%. You decreased by 50%. Okay, and the last one I had you do, excuse me, was 128 to 47, so that's a decrease. Okay, and so you subtract the two, you get, let's see, 81. Find where I was at here. So when you subtract 47 from 128, you get 81, and that is over the original 128 equals R over 100. Okay, cross multiply, 8100 equals 128R, and then divide by your 128 to find your R, and that's going to be 63.281, which rounds to 63.3. That 2 goes up to a 3. So 63.3% of decrease to drop down. Okay, so you drop down more than half. You know, half of 128 would have been 64. So, you know, if you drop by 6, let's say it's miles per hour or something. If you drop 64 miles per hour, you would have dropped half your speed. But it was more. You dropped 81 miles per hour to get to 47. So that's why it's more than half. You know, hopefully you're starting to see the implications of this, and it kind of makes sense. You know, it should always kind of make sense. As long as you follow your pattern, though, and follow your formula, amount of change. So we subtracted, got the amount of change over the original amount equal to R over 100. Then do your cross multiplication. 8100 equals 128R. And then to isolate the R, just divide by whatever is the coefficient here. And that's where you get your percent. Okay? So that was amount or percent of change. Okay? What I want to look at today is, you know, I had a couple days left here. There's so many things, you know, it's always so short, but basically I wanted to make sure we're clear on formulas, because really as you go on in math, if you take other math classes, you use formulas a lot. And then in everyday life, you're going to run into countless of formulas if you go into further things, as you know, if you do just jobs that require you to plug things into formulas, or if you do science experiments, or if you're just trying to do calculations, formulas are used a lot. And so there was a couple that I felt like were very, you know, important, and that we could look at, that you could take this and apply it to anything. So these are going to be your most basic, but the one I want to focus on, and I've shared this before when we did interest, but distance equals rate times time. So distance, that's what this one stands for, equals rate times, because they're written together, when they're written side by side means you're multiplying, times time. Okay, and in every, you know, so you know what we're talking about here is however fast you go, your rate, like if you go 50 miles per hour for however long, tells you how far you're going to go. Okay, and so the way this formula is set up is that way. So just as an example, if I go 50 miles per hour for 3 hours, okay, so that's rate times time, then I do 3 times 50 and I get that I'm going to go 150 miles. And if you think about that, 50 miles per hour for 3 hours, you know, you go 50 miles for the first hour, 50 miles for the second hour, 50 miles for the third hour, and you've went 150 miles. Okay, so that's how that formula is set up. I could do another one. Let's say I do 60 miles per hour for 2.5 hours. And I wanted to use a decimal, because this we also did when we did interest. And I want us to always remember, okay, that's 2.5. That does not mean 2 hours and 50 minutes, like 2.5 in that way. 2.5 hours is 2.3, you know. Now, as far as what we're going to plug in is 2.5. That's why I turned it into that. But just so we are clear, it's 2 hours, 30 minutes. That's 2.5 hours. So let's look at what happens there. So if someone told me 2.5 hours, or if they said 2 hours, 30 minutes, okay, that's where you have to convert that. Think about time. 2 hours, 30 minutes is 2.5 written as a decimal. It's 2 hours, 2.5 hours. Or that written as a decimal is 2.5. We did this with interest when it was like years, and we said 6 months. You know, that conversion was 6 months is half of a year. Or, you know, 12 months is a full year. Or 18 months is 1 year and 6 months. You know, we had to do that when we were doing it with interest. Well, here we're doing it with time in this way. So, you know, don't forget that conversion part of it too. But here we're trying to figure out, if I go 60 miles per hour for 2.5 hours, you multiply 60 times 2.5, and you also get 150 miles. So I sped up, and it didn't take me as long. So if you think about that, the first hour you went 60 miles. The second hour you went another 60, so now you're at 120. And then you went half, because you only went half an hour, you went half of that, which is 30. So, you know, here you went, for the first hour you went 60, second hour you went 60, and then you went 30, because you went half an hour. So that adds up to 150 miles, okay? So that is set up to solve for distance. If I do rate times time, I get my distance, okay? And that's pretty straightforward. That's why it's a simple formula. The only problem is, and this is why I wanted to use this as an example, is in life, we're not always set up to solve for exactly the way the formula is set up to solve. And very rarely, when you're planning a trip, are you trying to find the distance. Okay, very rarely are you trying to say, well, if I go 60 miles per hour for 6 hours, how far do I go? That's not how you usually plan out a trip. Usually what you're trying to find on a trip is, how long will it take me? You know, now I know in today's world we have GPS that kind of do that. You plug in where you're going and it does the time for you. I just remember back in the day when you were planning out a trip, you had a map that showed you how far, you already knew how far you needed to go, and you kind of knew if it was highways how fast you could go. What you didn't know is how long it was going to take you. You know, when you were planning out, and I still do it with Google Maps, is okay, how far, you know, I can plug that in, it shows me, and I'm kind of, what I'm trying to find is, well, I can make it in this far, make it in this much time. So now, what you have to do with that is you have to rearrange the formula, and we sometimes call it manipulate the formula. You're still going to use this formula, but now you need to rearrange it to solve for something else. If you look at this formula, what it's solving for is D. That's the variable that's been isolated. Okay, so this is what you plug in, this is what you're solving for. Well, to manipulate that means you want to solve for something else. You want to solve for something other than D. So let's say I'm trying to find out time. So instead of having D isolated, I want to isolate T. So to do that, I need to get everything that's with T on the other side of the equal sign. So instead of having a rate here, I want it over here. But I have to move it in a certain way. That means I have to, you know, I can't just, you know, in this case I can't just subtract it because we're not adding these two, we're multiplying these two. So the opposite of multiplying is to divide. So I've got to divide by R, I got to divide by R. What that does is those cancel out, so I've isolated T over here, and I'm gonna have to leave this written like this because I don't know what D and R are yet. Until I plug it in, I don't know what those are, so this is my new formula. Even though it's the same formula, I just reworked it, I manipulated it. Now it's set to solve for time. I'm still just gonna plug in distance and rate, but now I'm gonna get out time. So like I was talking, this is more common to what we do. This would be like, okay, I know I'm gonna travel, you know, to Philadelphia or something like that. Or, you know, I know I'm going to travel to St. Louis. Well, in that case, you know how far you're going. So let's say I did a problem where I'm going 600 miles. And I pretty well know if I stay on the highway, I can go 60 miles per hour. Okay. What I want to find out on my trip planning is how long is that going to take me? So in this case, the way the formula is if I plug in 600 miles, and I go 60 miles per hour, how long will it take me? Well, 600 divided by 60 ends up being 10. So it's going to take me 10 hours to go that far, okay? So instead of multiplying rate times time to find my distance, which we did on the first two, and you can go back and rewatch that if you're doing distance problems. Well, now to find time, I had to rework the formula, and I'm doing distance divided by rate. And now I get my time. Let's do another one of that. Let's say I know I'm going to go about 245 miles. That'd be more like St. Louis or something. 245 miles. I know I can go about 70, okay, an average of 70 on the interstate. So how long will that take me? Well, you know, I'm trying to find how long will that take me, my time. Well, if you do 245 divided by 70, you get 3.5. So it's going to take you 3.5 hours to travel that far. If you can go that fast and you're going that far, it comes out to 3.5. Okay, so that's the more common thing in everyday life is you're trying to find time. Well, same principle. Let's go back to original formula again. D equals RT. And instead of solving for D, which is what it was, where you plug these two in and multiply them, and instead of solving for time, where you move the R over here, let's solve for rate. Now, this would be like in a science experiment. This would be like, okay, you set up a distance, how far you're going to have this little car go, and you know how long it took. Like, let's say you're doing a science experiment, you got a stopwatch, and you clocked it. You want to know, well, how fast was that car going? That's like a science experiment where you don't necessarily have a radar gun or you can have a speedometer. That's what you're trying to find is the rate. So same thing, instead of isolating T, we want to isolate R. We want to get R by itself. Well, in the same way that we did time, we want to isolate that R instead of multiplying by T. This time, we're going to divide by T. That way it cancels out. But whatever you do to this side, you have to do to this side. So now my new formula is distance divided by time gives me my rate. See, I moved the time over here, but to do that I divided, and that's what that looks like. So let's plug that in. Let's say I went 300 miles, that was my distance, and it took me 3 hours, that was my time. How fast was I going? Okay. That way you plug in 300 divided by 3, you get that you were going 100 miles per hour. Okay. You went 100 miles per hour. And that's using these measurements, but you could use any measurements, inches, feet, seconds, hours, but in this case we were doing miles and hours, so that means I was going 100 miles per hour. Let's do another one. Let's say I went 270 miles, but it took me 5 hours. Maybe there was, traffic, and I need to average out how fast I was going. So I do 270 divided by 5, and that's going to give me my speed, my average rate of speed. And when you do that, you get 54. So I was going 54 miles per hour if it took me 5 hours to go that far. Okay. So that shows you how you can manipulate formulas to solve for whatever you're solving. Okay, so go back. Now I know I did 3 big things right there. Go back and re-watch them and make sure you're clear on which one you're solving for each time. But let me have you solve these. This is going to be your assignments. You'll upload these. First off, I want you to find the distance when you're going 60 miles per hour and it took you 4 hours. So here's your rate, here's your time. Now these are just the straight formula where you do rate times time. Okay, this is where you use, and I'm going to put the formula out here. You're going to use this rate times time formula. So this would just be plugging in this times this, okay? Okay, this would just be plugging in your R times your T over here, okay? Second one, same thing. I want you to find the distance when you are traveling 70 miles per hour and you're going 3.5 hours, okay? Then what I want you to do is do a couple where you're manipulating. So this time I want you to find the time, how long it took you when you were traveling 400 miles. So this is giving you the distance, and you go 50 miles per hour. So that's your rate. Okay, so now we've kind of manipulated, and this is where you got to take this formula and rework it to distance divided by rate equals time. Okay. So this is where you got to plug it in this way to get your time. Okay. Let's see, time. Let's do another time one. When you're driving 270 miles and you can go 60. Okay. And then the last two, we're going to have you find rate. Okay. When you still have your distance. Okay. And you have your time this time. Okay. And same thing, I'm going to have you find your rate when you went 195 miles and it took you 3 hours. Okay. So, this would be plugging it in. If you're unsure, remember this is the formula where you reworked your formula to distance divided by time is your rate for these last two. So these two go with that, these two go with that, these two go with that. So work those formulas and kind of get used to kind of working them around in different ways, okay?